So here's an example that does another evaluate functions for the given input, and I wanted to do the one that had the x plus pi. If you remember, pi it's a 3.14159 decimal approximation, you know, when you do circumference to diameter in a circle, but bottom line is it's a number. So we're doing the quantity of x plus a number into this function g of x. So again, anytime with function notation in evaluating, whatever is inside the parentheses, that's what you're going to plug in every time you see an x and apply whatever rules the function has you follow. So for this problem, we'll take the quantity of x plus pi and square it, and then add the quantity of x plus pi. So what we have on the left-hand side is a sum of a quantity that's been squared. And we want to, you can't square those terms. You can't just do x squared and pi squared. You actually have to do x plus pi times x plus pi. We'll end up adding another x plus pi, but we can't put those together right now. But the two on the left, you'll have to distribute, multiply out, do your FOIL method. So you get x times x is x squared, x times pi, and another x times pi is actually 2 x times pi's. I'm going to do 2 pi x because pi is a number. And then on the end, we'll do plus pi squared. And then we'll add x and we'll add pi. So now to combine any like terms, there's no more x squared. There's pi squared, and then there's pi, but those are two different numbers, and you can't really add them together like they are. So really the only thing you could, in a sense, combine would be these x terms. But it's not really going to look like much combo because there's 2 pi x's and then there's 1 x's. So together there's 2 pi plus 1 as a quantity on the x. I know it doesn't seem very simplified, but you got x squared, then the x coefficient is 2 pi plus 1, then there's a pi squared plus a pi. And that is, for what it's worth, the final simplified answer to this problem.